everyone. Thank you for coming for today's presentation. Okay, the purpose of today's presentation is that we all need to have a basic understanding about BIM as a new technology in design, because in future, and I mean in the near future, we'll be replacing the old traditional way of design using AutoCAD by the new technology, which is BIM, using the Revit software. So here we will have only introduction about BIM, the basic about BIM, motivation, why to use it, how we will use it in the future. The rest will be coming step by step in the future. Before I get into the presentation, I would like to announce to you that decision has been already taken by Mr. Sapour to transform the whole company from CAD design to BIM design. And this will be not in a single day or 1 month, or it will be in a time, stages, one by one. You don't need to worry about anything. Everything will be set for you. Just we need to follow a good plan. And people used to resist change. So you may think in the beginning that this is something difficult. Why do we need to do it? We used to do AutoCAD in 10 years, maybe more, or more than 10 years. Yeah. So this is better way to keep it in the old way? No, this is not true. The truth is this is a new technology. We need to follow. Before, people used to use their hands, pencils and pen, and then AutoCAD came, replaced the old way. Now BIM is coming. It will replace the design of AutoCAD. That means in a time frame of 1 year, maybe more or less, we will not be using AutoCAD for design. We still need AutoCAD for exchanging drawings with contractors, authorities, whatever. But in design, we'll be using only Revit. I don't see it, I don't think you'll see it. Or beside Avyasir. Okay? And I will be responsible for that transformation. I will be the one who's setting the plan. You don't need to worry about anything. We are all responsible for executing that plan and doing whatever needed. So you don't need to be worried. Just relax and be motivated about this new system. So our presentation today is Introduction to BIM, Definition, Vision, and Future Implementation. So in definition, I will answer 3 important questions. First, what is BIM? What is the difference between CAD design and BIM design? And what is the difference between BIM and Revit? So what is BIM? If you go and search in the Google or watch YouTube videos, you'll find many definitions of BIM. They are all true, but we'll try to simplify things and to find a good definition that we will be benefit from. For example, one definition is, of course, BIM stands for Building Information Modeling. This is the acronym for BIM. Building, or in other way, it's modeling of building information. So we are modeling information. We are not drafting in using BIM. We are modeling information. What type of information? Any information in the building that can exist in one building. For example, geometry. This is the basic information. We are using it in AutoCAD, drawing length, width, thickness, whatever. This is one type of information. Building size, home size, whatever. Material properties that also can be modeled in the using BIM. Ducts, insulation, concrete strengths, doors, material. This is all material properties that also can be modeled in the BIM model. Specifications like paint color, electrical sockets. You can even write the supplier name in the model, put it in that. This all kind of information. Time also can be, for example, construction process. Then we are talking about 4D design. And cost, of course, then it becomes 5D design, if we include the cost into that. These all type of information and many other information that can be included in the model. So this is not drawing, this is information. I found this simple definition of BIM. It's a process used by architects, engineers, owners, and contractors to coordinate design between disciplines in a 3-dimensional environment. So first of all, this is a process. This is not a software. BIM is not a software. It's a process. It tells us how to do design in some way, different from using AutoCAD. And the other thing is coordinate. The main purpose of BIM, the main idea is to coordinate design, to avoid problems in early stages before it go to the site and comes back to us with the problem. So coordination is very essential in BIM design. And of course, the big jump here, the main difference between AutoCAD and BIM is the three-dimensional. We are working in three-dimensional environment now.
Yeah, can we say that when we are using BIM, instead of making drafting as a line identity, we are doing elements with its all identity, size, color, texture,
Yes.
whatever. So we are doing things, not lines.
We are constructing the object as we are doing it in the site, but instead we are doing it in the computer. So any problem that may come in the future in the site, we can avoid it in early stage in the design. We are not drafting, we are modeling objects, real objects. With BIM, a virtual model of the building is constructed into the computer where every team member has his own part to add. So everybody, the architect, the structural engineer, even the IT people, the schedules, anything, anybody can come to this central model and do his own part. We are not working separately. We are working all in one place, all together. This is the idea, virtual model. We are constructing our building into the computer.
And it can be said that Firdaus can come to this model and say,
anytime.
this is stage being
Yes.
invoiced.
Yes, of course.
This
She can.
stage is
Yeah.
being invoiced.
Anybody
Yes.
here, anybody. This is why I insist on anybody here that comes, that go to the model and do his own part, even if it's small. For quantity surveyor, he can come and take out schedules. For drafting, we can take drawings. We can take any information. Even visualization is kind of extracting information from that model. So another definition for BIM is an integrated workflow based on reliable information about project from design through construction and into operation. So we are not talking about one single operation. This is a workflow that continues from design to construction and even beyond that to operation. Yes, for facility management, maintenance, whatever, they can still use that model. So BIM is from day zero, from the project, since it's scratch,
Yeah.
until the building is
With
live,
operation.
until the building is demolished, for after its age is finished. That's it, from day zero to the final, to the end of the building life. This is a example for virtual model. Anybody can add his own part. See, this is architecture model. The MEP people will do their parts inside, and also the structural. In this integrated workflow, the entire design team is working on creating a single building model. We are working again in one place to create one single model. Once the design is complete, drawings and schedule, of course, can be easily generated. It's one click, you can generate any drawings you want from that model. This model represents the actual building that is to be constructed, of course. The model then can be handed to contractor who use it for visualization, material takeoff, and construction process. This is one part of the workflow that after design, you can deliver it to the contractor. He can go inside the building and look at it and define what is constructible, what is not, what is easy, what we can change in early before it's real in the site. So this is part of the workflow, design, construction, and into operation. Okay, I have this small video. This is very basic and very interesting to watch. It's only 3 minutes. Don't get bored.
What is BIM? BIM is very much talked about in the building industry, but what is it really? What is it used for, and who should use it? Some say BIM is a type of software. Some say BIM is the 3D model of buildings. Others say BIM is a process, or that BIM is nothing more than an organized collection of all building data. BIM is all of the above and more. Now let's see BIM explained in layman's terms. When it comes to BIM, everything begins with a 3D digital building model. This model, however, is more than just simple geometry and some interesting textures added to it for visualization. A true BIM model consists of the virtual equivalents of the actual building sections used to create a building. These intelligent elements are the digital prototype of the physical building elements such as walls, columns, windows, doors, stairs, etc., that allow us to simulate the building and understand its behavior before the actual construction begins. Now let's see what a BIM model can be useful for. 3D visualization. Of course, the most basic use of a BIM model is for creating realistic visualizations of the planned building. Your BIM model helps your design decisions by comparing various design alternatives and for selling your design to your client, the local community, and other stakeholders as well. Change management. Since data is stored in a central place in a BIM model, any modifications to the building design will be automatically replicated in each view, such as floor plans, sections, and elevations. This not only helps in creating the documentation faster, but also provides stringent quality assurance by automatic coordination of the different views. Building simulation. BIM models contain more than just architectural data. Information about the different engineering disciplines, sustainability information, and other characteristics can be easily simulated well in advance of actual construction. Data management. BIM contains information that is not visually represented at all. Scheduling information, for example, clarifies the necessary manpower, coordination, and anything that might affect the outcome of the project schedule. Cost is also a part of BIM that allows us to see what the budget or estimated cost of a project might be at any given point in time during the project. Needless to say, the data put in a BIM model is not only useful during the design and construction phase of a building project, but can be used throughout the entire building life cycle, helping to reduce the operation and management cost of buildings, which is significantly more than the entire cost of construction. With all the benefits BIM has to offer, don't let your competition get to BIM before you do.
So, this is only the definition. It's very simple, very easy to understand. Now we know what is BIM, what is the BIM model consists of. Let's compare it to CAD design, what we are doing nowadays. So CAD versus BIM. CAD stands for Computer-Aided Design, BIM, Building Information Modeling. In CAD, CAD for like AutoCAD, a drafting tool to create lines and arcs to represent design. So we are drawing lines, arcs, you know. BIM tools allow actual building elements to be placed into a model. This is again talking about objects, elements. In CAD, focuses on end documentation only. So we are doing only drawings. This is our focus on drawings. In BIM, focus on creating complete building model, and the drawings can be easily generated from that model. In CAD, team members work on drawings independently, though they are connected with X-ray, but still X-ray is a poor connection between the disciplines. Everybody is working on his own. We have maybe drawings, structural drawings, and architectural drawings. But in BIM, all team members work together.
And also, fighting.
And fighting, of course, all the time. I'm not reaching solution at the end, and then somebody interface, and then the contractor will come again. Okay. Information needs to be updated every time we change. I have to go and tell, for example, Anish, okay, I did that. Be careful about that. Do it in your art design. But in BIM, all information is up to date. Once I change something, everybody will see it because we are working in the same place. It's like we are here all. I came and moved that chair. Everybody knows that I moved that chair because we are in the same room. Draw plans for elevations and sections. In AutoCAD, we need to draw all these. But in BIM, create elements in one view, and then they appear in all the views. so you don't have to replicate the work. The question we need to answer is what is the difference or what is the relation between BIM and Revit? BIM is a design process, as we saw previously. This is a process. It tells us how to design. It's not a software or a design technology or a method for building design. Anything you can choose, this is correct. Technology, process, or a method. But in Revit, the Revit is software. It's like AutoCAD. It's a software designed for BIM, and it's a tool to apply BIM and 3D design and 2D documentation application. So this is application. This is software. It was originally designed to implement the idea of BIM. So BIM is the idea. Revit is the application of that idea. So at the end, they are not equal. So let's distinguish these things from. BIM is not equal to Revit. BIM is there are another software, by the way, like that one, I forgot his name, but we are focusing on Revit because we are going to use Revit in our company. From initial design to construction documents, Revit uses tools specifically designed for your discipline. So every discipline has its own tools. That tools are Revit for architects, for structural engineers, MEP engineers, and for construction. Each of them has his own tools to make their own model or own objects. Modeling building geometry in Revit is not like modeling with a visualization tool such as 3D Max. It's not only pictures we are taking from the model, it's all type of information. In Revit, we model using objects that behave like their real world parts, like we saw previously, doors, wall furniture, ductwork, equipment, columns, and beams. In Revit, you can work from within any view, including schedules, and the data and graphics of your building model will be always in synchronized. That means if you change the door in a plan, it will be changed in the elevation section and also in the 3D model. Even in the schedules, it will be changed. Now we'll see example for that. So an item is never going to be displayed correctly in a floor plan, but incorrectly in elevation. That's impossible in Revit. You cannot see a door 2 meter by 1 meter by 1 meter in elevation, and then in the section it will be different size. It will be exactly the same size. Either it's always correct or always incorrect. That's it. The real power is not the graphics, but in the information behind the 3D picture. So let's just go to the example. The small example I prepared. We have this building. So we have this model, for example, it's built in the software. And in this model, I will show you this. This is an elevation. This is the model. We are focusing on this particular window. Look at this window. In the 3D model, here it's in the plan, this window in the plan, and this is the section into the window, and this is the elevation of the window. So if you choose in any view, if you choose this window, you see it's highlighted in the elevation, in the section, and in the plan. So we are working on the same object, but different views. So for example, I want to change the size of this window from 36 by 48 inch to 24 by 72. I am working on the 3D view. So what happens is it changed in all the views. See, in the plan, the width changed. In the 3D, I'm working on the elevation and in the section. So you don't need to worry about anything. You just change in one place, it will appear in all places. This is only the simple example. Let's go back. So, vision, our vision to BIM, how we look to BIM, what do we expect from BIM? Why do we need to implement BIM? So there are a lot of reasons. First of all, the BIM enhances vision. What BIM will enhance for us as a design company. First of all, BIM tools will enhance our company's technology in building design, which help us provide superior services to our client. This is the future of design. If we follow, we will have better tools and better services to provide to our clients. BIM will enhance coordination between all disciplines, which improve the quality and reduces confliction and inconsistency. How many times did we have problems in the difference between structural and architecture, MEP and heating, sometimes clash we have between all members. So in BIM, we try to avoid that problems. This is the better way in design. BIM will enhance collaboration and communication among all team members, which improve the work environment and motivate us to work as one unit. We have a big problem here, let's face it, in our office, that we don't have a lot of communication. Everybody is working on his own. Maybe some small meetings here and there, but we don't have that strong communication like in the professional way of design. So BIM will force us to do this communication and collaboration to work as one unit. Let's see this example of communication. Thanks to BIM, I have doing this example. For example, we have user one working on a project. This is the plan. We will focus on this particular column. And we have also user two working on the same plan, different computer. And this is the column. And the user one, and let's assume he's an architect, he came and shifted that column to the center of the wall, thinking that this is a better way for the column. In the same time, it happened that this user two, for example, his structural engineer, he thought that no, this column need to be on the edge of the wall because my beam is here, I don't want to get out of it. So the user two came and moved the same column which was moved already by user one. So the program tells him, no, this is error. You cannot edit this element until the RUBC 15, the other computer, give you the permission for that. So you cannot change that column. So you have to call that user and discuss with him this type of communication. Or you can place a request from the computer, from your model. You ask him to place a request to allow you to edit that column. So once you place that request, he will tell you that your request has been placed to the user. You wait for his grant to allow you to edit that. In user one screen, he will see this message that computer, for example, Dima computer wants to edit this column. He will write the name of the column, all the information about that column, particular column. So will you allow him? Maybe user one think that no, I don't want this column to be here. So he will communicate with him. He will tell him, no, why do we need? Okay, let's find a better solution. So this is kind of communication. Sometimes we don't worry about, because in AutoCAD I can shift the column and let what happen there later. You know. So he will say, okay, if he grant, he will allow him. Then a message, your request has been granted. You are allowed to move. Now the column is actually moved from the center to the edge. This type of communication, this is very strong tool in using Revit, and of course it's benefit in our design.
In reality, you don't need to see him. If you would send him this request,
Yes, of course. If he doesn't mind, okay, he will just grant you, okay, move it, whatever you need. Or he may suspect that, okay, there's a better way, let's discuss. He will call, or maybe see this type of communication that we need in our design. BIM alters vision. What BIM will replace? What will BIM will change? That was enhanced vision. Now alters vision. BIM will replace our traditional design method with a modern design process, which is the future of building design. That's it. BIM is the future. Either we like it or not. This is the future. We have to follow. BIM will change our organizational structure to more organized and clear duties where everyone is responsible for his own part. Because BIM is based on coordination, so everybody knows his own part. Not like AutoCAD when some duties are mixed between people. You know, somebody is changing what he hasn't shouldn't change. So in BIM, that will better organization and duties, it will be assigned to everyone. With BIM, we will be recognized as a professional and high-quality engineering company in the local market. Of course, when, for example, in Fujairah, when we are known as a BIM company, that will be very credit for our company in front of all clients. BIM will alter the way we control contractors and suppliers. by having a better control over our own design and minimizing errors and RFIs coming from the site. When we have model, we did that model, we give the contractor that model. The contractor will not be able to change in that model or change in our design like they do in some of our designs without coming back to us and let us know or we change in that model. So we have a better control on our design.
So the contractor will know how to weld the
Yes.
water pipe from day one.
Before it goes to the site. Clash detection as strong tool for Revit to reduce or eliminate the clashing between beams, doors, ducts. This is very, very strong tool in Revit. Using another software, Navisworks called. Now we'll see example, just let me read this, to provide high quality presentation and construction in drawings as exported directly from Revit model. So let's see this example about clash detection. Okay, we have this, again, thanks to Lima. We have this small model, small room. We did it using the Revit and exported to Navisworks. This is Navisworks. We will do the clash detection. On purpose, we draw this beam to clash with the door. And we have another internal clash. Now we will see what it is. So we run the clash detection. It's here. Okay. Now I want the program to detect the clashes between the model and itself.
Yeah.
So whatever clashes there is, show me all the clashes. So I tell him run test. He gave me 3 clashes. The first one, if you go down, he's showing here, highlighting the beam with the window. He's writing here window and structural framing, whatever it's called. So this is the first clash. The second clash is this beam with a duct. You can see here the duct is touching the beam. Maybe this will face a lot of time in our design. Sometimes we don't know that this duct is not passing through. You see, he's writing duct and triangular beam. And the last one is the same one with the door. The beam is clashing with the door. So in this type of tool, this tool will help us to reduce or eliminate the problems or mistakes in our design.
Here you request the program to show you if there's any clashing or not. I'm wondering while you are doing, you will discover that there is something happening without asking the software to give you the clash.
There are some cases when you draw something above something, he will tell you. But I don't know if he's able to warn you through the modeling. No.
If it's
Some-
not at a beam, no. But if it's a wall and a wall.
Yes.
Or
If
column and
two
wall.
walls overlapping, he will warn you inside the model. But here, no. For different parts,
it's a-
you have to run the clash detection. So let's continue the goals. Increase productivity by cutting off the time needed for drafting. In the first, you will see you will need a lot of time doing that and learning the software. But once you are good in using Revit, you will decrease a lot of time needed for doing that in the using AutoCAD. For example, if this building, if we go back to this example. For example, this one, how long do you think you need, how much time you need to make a section from here to here? 1 day, Anish? Half day?
More than
Half day.
Not half day, more than 1 day.
How about to do that in 10 seconds? By telling him, I need a section from here to here. And just show me this part. How about that? This is the section.
Very nice.
Section is ready. I don't need to draft.
Very good. Very good.
It's ready. It's 10 seconds. And even this, but the mouse here is sticking. We need to.
Because you are building it.
Yeah.
Yeah.
From the beginning, you are
So,
building the.
Once we build it,
Yes.
that's it. We can generate anything we need.
Whatever we cut.
Whatever you cut, and there is even a better way for section. There is 3D section. You can see the building, but you cut it in two half. This is a better section in the future. It will be. So this is, you can imagine how much time. You don't need to worry. If you change the height of the building, you change it in one view. You don't need to draw again. You how many sections did you make in the Masjid Anish? How many sections? You don't need to say, huh? You don't need to say. So, see, as many sections you need, you can do
And what about the elevation?
whenever you need. There are also elevations, of course. This is not straight, but it's good. This is the elevations. It's ready. There are elevations here. See this small rectangle, and you can replicate elevations whenever you need. You want to come here and see this elevation?
And 3D
You are most
also.
welcome.
3D can be.
3D always. There is always 3D. This is the 3D building.
Wow.
And you can come here and tell him to do a 3D section in the building. You know how to do 3D section? We'll see in the future. Okay? So let's go back. I think this example is more interesting than this boring presentation. So simplify documentation, provide new services and deliverables such as 3D sections. This is new. If we can include it in our drawings, it will be new for everybody. Barbell schedules and realistic drawings. Maybe color plans we can provide. Improve coordination and accuracy of design deliverables. Quickly and accurately identify the implications of design change. Change is now easier than before. It's very easy. You can change and manage that change very easy. Improve soft skills. Of course, your skills all will be improved. You have a new skill. Increase client certifications. Then, a lot of goals. Involving contractors and suppliers in the design process by changing information and construction process and equipment installment or sending them the model if required. So we can from beginning ask the contractor to come and see the model and let's take his opinion about constructability of some elements. If this can be done in other way, let's from beginning do it. This is much easier to do in 3D dimensional.
Of course, in that model,
Right.
we can always pick up the area and to know how big it is, square meter, or whatever.
Any information can be generated. Any information. You don't need to calculate the quantities anymore because when I put this wall, it will be already put in the schedule and the quantity for that. You don't need to. You just make output from that one. Sending the Revit model to clients for visualization and future facility management and maintenance. To become leading company in BIM in the region and ready to interact with authorities and other engineering companies when BIM is more recognized and required by municipality. In the future, the municipality will require BIM. So we don't want to come there and to come to that time and then start learning. We want to be ready. Even we can advise other companies or with the municipality. We can give presentations, whatever. We are ready. So now we know what is BIM. We know our goals for BIM. Now the implementation. How we will do it. What do we do? What do we do next? How we will implement that one? Okay, we are motivated. We like the idea, but we need a plan how to do it. The first question is, can we just buy the Revit software and get on with it? Okay, through the next slides, we will know the answer, the long answer for that. But the short answer is no. You cannot just buy the Revit software, put it in computers, and ask people to come and work on Revit. Because all the failed attempts to implement BIM in engineering company around the world were related to improper planning. So we need to have a plan for that. We cannot just buy the software and get on with it. We need a plan. it's not that complicated. It's just headlines to know our current situation and what we are going to do in the future and who will be doing that. BIM cannot be implemented individually or by personal attempts. All the personal attempts we tried before, we hit the wall. We came up with a model, we didn't know what to do with it. So because we don't have plan, we don't have goals, we don't know where we will reach in that model. So if we plan for that and know our goals, then we will have a criteria to assess the success, our success. Implementing BIM should be based on a proper plan which provides the guidance that we will need in implementing BIM with the least problems and best result. As long as we have a plan, it will be our reference. We can come back at that plan anytime. We can revise that plan and progress will continue.
Like, give us the plan, you scared us now. Give us the plan straight up.
Yeah, what is that plan?
I have a question. So when you're sharing this with the contractors, even they need to have that software to run
Yes,
it
of
to
course.
see.
At
Only
least
then.
they need to have the what is called the
Revit
viewer. Yes.
Okay. So
At least they need to have viewer for that, or we can send it
and if they
online.
don't have that kind of knowledge, then it's easily convertible into AutoCAD and to send it, push
Yes,
it off.
but
Like
yeah,
how we
we
save
can
documents as Adobe or
we can
something.
anytime extract drawings from that model and send it to them.
Send it to them as a
Yeah. At the end, we have to send drawings for contractors.
Yeah.
All drawings are already there, 2D drawings.
Okay.
You know, but this is more information are in the model
Yes,
that we can
absolutely.
use anytime. So BIM successful implementation, in order to successfully implement BIM, we need to do 3 important steps. The first one, preparing for change, which we are doing today. We are preparing ourselves. We didn't start yet, but we are preparing, getting everyone on board. That's why we ask everybody to come here today, so you know that all of you are involved in that transition. Understanding the reasons for transition to BIM, now we know why we are going to use BIM. Support and commitment from management, of course. So we have all this support in this transition, giving responsibility to a BIM leader, to one person who will be responsible for that plan. I will be the one who will put the plan and discuss it with you all. Anybody has an idea or something to discuss, let's discuss it. But I will be your reference whenever you need to ask question, whenever you need. That doesn't mean I know everything about BIM, but at least I can know from where to get the answer. Or at least now we are 2 thinking of answer for 1 question. Planning. This planning, you don't need to worry about the plan. The plan will be set for you. You just need to execute that plan. I'll be understanding our current situation, benchmark. We need to set a benchmark that in the future we can come back anytime and say, okay, we used to do it in this way, but now we are reducing time doing this thing. This is a good improvement in our design. So this is a benchmark, understanding our current situation. Identifying requirements and goals, what I will need, hardware, software, people, staff. This identifying requirements, clear assessment criteria to monitor progress. I need to have clear criteria that at every stage I know that we are improving or we are still running in our place. So I need to set this criteria. Documenting the plan, of course, it has to be written in 1 PDF file. This is our plan for our office, specifically designed for our office. This is the plan, everybody can access that one. Execution, it's our responsibility all to execute the plan. Training, the first step in executing is training. Now, starting from next week, we will have every day 1 hour training. The training will be a series of videos, professional videos taken from a professional trainer for training. So we will sit all from 5 to 6, right?
Is that okay for everybody? I think 5 to 6 is okay, isn't it? That's really good.
5 to 6, yeah. And we need to see videos, learning step by step. Everything you will need, you will learn. Don't worry, just listen to the videos. I will arrange that videos for you. Step by step, we'll get into the program, the software. And every day we'll get to know things better than the previous day.
Do you prefer to play the video and we are watching, or you prefer to play and we are working with you?
In the
What-
beginning,
what all you
yeah,
prefer?
in the beginning, it will be watching videos.
Watching
Yeah,
videos.
before getting into the software and
So
working.
to know the software.
Yeah, to know, to have an idea about the software,
Yes.
the ribbon and whatever the interface. And then in the down, we'll get the screen down, and everybody is sitting on his computer. He'll start applying whatever the video says. This is a good way for learning. Believe me, I learn in this way. I didn't need anyone. I just watch video, do whatever he says, and that's it. You learn. Of a standard and procedure, this is in the next step. We need to define our procedures and standards in the drawings. Maybe we have some changes in the layouts, title blocks, whatever. This is our standards. Pilot project. The pilot project is the first project that we will start doing it using BIM. We will not rush. We'll take our time. You will get into the software. You will learn it well. Then we choose a pilot project. The pilot project doesn't need to be very simple or very complicated. It needs to be something that we used to do, something typical for us. And once we start this pilot project, the other projects will be easier. We will learn from our mistakes. Team selection, of course, for every project, there must be a team for that. As a summary for the previous steps, not very long for you, current situation, identify requirements, set goals, identify actions, detailed planning, training, hardware, standards, team selection, rollout, to continue with other projects, and then review our progress, and then go back and change in the plan. So this is the planning, and this is the execution. We can, after execution, we can roll out to other project and go back and review it, and maybe we change in the plan. So this is an open topic for all of you. It's not a restrict plan that it's very open. You can come and okay, I have an idea. Let's do it in this way. You know, everybody needs to have his own. We will learn together everything step by step. You just need to be motivated and ready for learning. Implementation needs to be viewed as a business investment. An initial decrease in the productivity, of course we expect that at the beginning, can lead to large gain in the future.